Hi, today's notes are on 6.5, properties of logs, or logarithms. When we solve logarithmic equations, the equation must be in logarithmic form on one side first. And another way to think of this is you can only have one log on a side, or one logarithm. So in order for this to happen then, sometimes we might have something like log base 7 of 10 plus log base 7 of 5 equal to something else, right? And if there's two logs on the same side, we need to be able to combine them. And so we need to combine or condense or simplify the two logarithms on a side. We'll need to use something called properties of logs. And before we do that, let's just do a quick reminder that exponents with base b, which is any base, and logarithms with base b are inverse operations, but they have to have the same base. Okay? And so let's then take a look at what we know about properties of logs. We know that if we have x to, say, like the second power times x to the third, that means I have 2 x's and 3 x's for a total of 5, right? And we're adding the exponents up. Let me just write that down here. For example, that means I'll have 5 total. So really what we're doing is we're taking a plus b to combine them into one exponent base. When we're dividing, we could have like x to the 10 over x to the 8th, right? We can write them all out, and all of them cancel except for 2 of them. So we could also think of it as a minus b in order to simplify things. Okay. When we have this, that means I have like b groups of x to the a power. So like if I had x squared to the third power, that means I have 3 groups of x squared, x squared, x squared for a total of 6. So that would be x to the a times b. Okay. So let's move backwards then and assume that if logarithms are the inverse of exponents, then their properties must also be inverted. They're very related, right? So here it used to be like if I have 2 that I'm multiplying, it becomes addition. Well, here if I'm adding 2 logs, then it becomes multiplication. And again, if I have 2 that I'm dividing, it becomes subtraction. So if I have 2 logs that I'm subtracting, then it becomes division. Now when I say division and addition, we're dividing the arguments. Okay, so whatever comes first goes on top. So log base c of a minus log base c of b. C is just any base, but we're going to make it into one log and divide them. And when this happens and you have a times b, we're going to make it into an extra exponent, just like we did here, right? Except it's opposite. So when we make it multiplication, it becomes an extra exponent. So we'll have log base c of a to the b power. And so these are just things that always work, and we should have these memorized. These properties of logs come from the properties of exponents, so these make sense logically, and these not so much, but we could check to make sure it works. Let's just check and see. So if I have, say, log, say 7 plus log of 8, okay, so that's log 7, log 8, what we're saying is that this should then be log of 7 times 8, but only one log now. And so you see that those are the same. Let's check another one just to be sure. Let's do log 7 minus log of 8. And then we will divide. That works so far as well, right? And then let's say 7 log 8. That's this. Well, then what we're saying is it should be the 7 could become an exponent. 7th power, like this. And notice it's still the same. Okay, so these properties always work. So what we're going to do is we're going to write the expression that we are given as a single logarithm as a single argument. So what that means, we're going to simplify the two logs into one, but we're also going to simplify this argument into a single number. We're going to show each step for full credit. Okay, well, this addition problem will condense to a multiplication, but the thing you want to remember is that it only condenses if you make the logs combined, right? You have to condense them together. So we're going to have a single log base 7, and then I will have 10 times 5, which is log base 7 of 50. You can also write it as log base 7 of 50, right? So it doesn't matter if you use parentheses or not. It only matters when you're entering extra things in your calculator. Okay, so the addition becomes a multiplication when you condense it. The subtraction becomes a division when you condense it. Okay, when we say division, we're dividing the arguments. So we'll have log base 3 of 25 divided by 5, which is log base 3 of 5. In our last example, the number in front is a multiplication by 3, and so that becomes an exponent. It'll be log, that's an invisible 10 of 2 to the third power, which is just log of 8. So I'll do 3 with you, and then I'll do like one more just to show you, and then I think I want you to try these yourself. But if you think you're ready, pause the video and try 1, 2, and 3. They should be exactly the same. I strongly recommend that you try that right now. So addition becomes multiplication. Division becomes, subtraction becomes division. This one's a little tricky. 4 can be written as 2 squared. And when you have these the same, you can actually cross them out, because log base 2 of 2 is just 1, and that equals to 2. This 4 becomes an exponent, so it'll be log of 3 to the 4th power, which is log of 81. Okay, so what happens when we have additional addition and subtraction problems? Well, it's still the same. This becomes, addition becomes multiplication, subtraction becomes division. This one we can do two things, right? We're going to have a division problem, but we're also going to move the exponent. This last one will have two division problems, but we are also going to move the exponent. So how do we write this then? Well, every single time there's only one log. Okay, so this one will be log of something and log base 2 of something. Okay. We are going to have 4 times 11 divided by 2. Simple as that. And then we can simplify that. Now, instead of doing 4 times 11, 44 divided by 2, I can just simplify 4 and 2 to be log base 8 of 2 times 11, which is log base 8 of 22. The other way works as well. Okay, in chapter 7, we're going to see that being able to simplify fractions and make the number smaller is much easier than multiplying. Okay, so this one will have 3 to the 4th power divided by 9, which is log of 81 over 9, log of 9. This last one will have 400 divided by 5 squared, and then divide by just means it's also on the bottom, right? Because if I had 400 divided by 4, that's what it would look like, and if I had 400 divided by 25, that's what it's look like. Okay. This can simplify to 100. So I'll be 100 divided by 5 squared is 25. It'll be log base 2 of 4. which is, again, we know log base 2 of 2 squared is 2. So let's summarize. Adding 2 or more logarithms can be simplified to multiplying the arguments of a single log. If we're subtracting 2 or more logs, we can simplify it to dividing a single log, or the arguments of a single log. And the coefficient of a logarithm can be simplified to the exponent of the argument of a single log. So hopefully this all makes sense, and this is one of those topics that seems really straightforward when you're first learning it and is so easy to forget later. So just make sure this all makes sense to you. So let's work backwards now. If we have log base c of a times b, right, we can also expand, and this is because in a moment you're going to see, what if I know certain logs, or the logs of certain arguments, but I'm asked to find the log of a different argument. Okay, and if we can mix and match these arguments to make 5, then somehow we can substitute these. Let me show you what I mean. So log base a times b is the same as log base c of a plus, log base c of b. When we divide, we can expand it and subtract. And then this b can go backwards and come in front. Okay. So let's take a look. I know log base b of 2. Okay, let me highlight that just so you see it. I also know log base b of 3 and log base b of 10. And we want to find log base b of 5. Well, let's expand our logarithm then to more than one log in order to evaluate. So if I have 5, I don't know 5 here. Okay, and I can't just take 2 plus 3 is 5. That's not how it works. I need to use multiplication and division here. So I could take 10 divided by 2 in the single argument, right, because I'm focusing on just these. And we can only use multiplication or division to expand. Well, then I can say 10 divided by 2 is 5, but instead of writing it as one log and a fraction argument, we can expand it to say log base b of 10 minus log base b of 2. Because once I have this subtraction problem, instead of log base b of 10, I can put in 1.7 and subtract log base b of 2, which according to this given right here is 0.5. So once I substitute the value in, then I can just subtract it, and I have 1.2 equals log base b of 5. Let's do that again. Okay, so we're given the same values, and I always have to give you these in order to continue. Okay. So let's start. I don't have an argument of 6 here, but I do have an argument of 2, 3, and 10. So how can we multiply or divide to the argument, right? And we have to use the given arguments. Sorry. Okay, so 2 times 3 is 6. So we're going to show all our work. Ready? You need to show, sorry, that's a b, of 2 times 3 to show that's why I chose those numbers. Okay. And then you have to expand it. So the multiplication becomes an addition. And then I can substitute and say log base 2, b of 2 is 0.5. and log base b of 3 is 0.8. Add those together is 1.3. To get to 5, earlier we did this problem already, so we can't multiply to get to 5, but we can divide. So we'll do log base b of 10 divided by 2, which means I'm going to then expand. And these I know, so I can substitute in. And I have to be given those. Eight is a little bit tricky. Like, look, I don't have any, like 2 times 4 is 8, but I don't have a 4. However, I do know, here's 2 ways you could do it. You could do log base b of 2 times 2 times 2. Or you could do log base b of 2 to the 3rd power. Okay. It just depends on how your brain works. So if you did it this way, you'd have to write log base b of 2 plus log base b of 2 plus log base b of 2. I'll show this one over here. Okay, so log base b of 2 plus, right, so all of these multiplications become additions. And then you can add 1, 2, 3, which is 0.5 plus 0.5 plus 0.5 equals 1.5. Another way you could do this is if you wrote this out this way, then you could bump the 3 to the front as a coefficient. And so we'd have 3 log base b of 2, or 3 times log base b of 2. And we know log base b of 2 is 0.5, which is also 1.5. Okay, give it a try. 1, 2, and 3 are the base level ones, and then I will go over 4, 5, and 6 a little bit more in detail. But pause the video here and give it a try, please. And I'll give you a hint to get started if you need. Oh, number 2 is already given, right? Like, it's very simple already. You just have to rewrite it as 2. So tell me what those numbers are. This one is going to be 3 logs that we're going to be adding. This one, again, 3 ways. You can do 3 times 3 times 3, or you can do 3 cubed. So it's sort of like a puzzle. You just sort of have to figure out how to get to 60, right? And so I know I'm going to use 10, and it's 10 times 6. So this could be I know I'm going to be subtracting 3 at some point, right? But 40 is 2 times 2 times 10 over 3. And then this one you can just cross those out and get a final answer of 10. Okay. Hopefully this all makes sense. I'm going to pause the video here and get some answers to just throw in there for you to check your work. Okay, so I caught a mistake that I don't know if you caught for me, but we didn't have an argument of 5 given, so I couldn't do 2 times 2 times 5. But I could do 2 times 10 to become 20. Okay, check your answers, and be sure you read this last 3 lines at the very bottom that says you need to show how you get the argument using the given argument, so that's my first step always. Then you need to expand the logarithms into multiple logs, and show your work for substituting. So a lot of students jump from here to here to here, and they sometimes get it right and they sometimes don't, but I also don't know if you understand what this is doing. So please make sure you show this part in blue. Okay? That concludes today's lesson. Let me know if you have any questions.